On November 12, 2025, at 3:47 a.m. Greenwich Mean Time, something changed. A radio astronomer whose name we still don't know was conducting routine observations at the Green Bank Telescope in West Virginia, monitoring background radio emissions from the region where 3I Atlas had disappeared behind the Sun 2 weeks earlier. The object itself wasn't visible, hadn't been visible since late October when it reached perihelion and vanished into solar conjunction, hidden behind 150 million kilometers of incandescent plasma. But radio waves don't care about visible light. Radio telescopes can detect emissions through the solar glare, through the corona, through obstacles that would blind optical instruments. And at 3:47 a.m., the data stream showed something that shouldn't be there. A pattern, not random static, not the chaotic hiss of cosmic background radiation, not the predictable pulses of known pulsars or the broad-spectrum hash of solar interference. A pattern, repeating, regular, structured. The frequency was 1420-4256 MHz. If you know anything about the search for extraterrestrial intelligence, that number should make you pause. It's the hydrogen line, the most fundamental frequency in the universe, the wavelength at which neutral hydrogen atoms naturally emit radiation. It's called the universal frequency because any technological civilization anywhere in the cosmos would know about it. Hydrogen is the most abundant element in existence. Its spectral signature is a constant, a universal calling card. When SETI researchers talk about where to listen for alien signals, 1420 MHz is always on the list. It's where you'd broadcast if you wanted to be heard. And now, according to reports that are spreading through amateur astronomy networks, through closed academic channels, through whispered conversations at observatories across 3 continents, something at that exact frequency is coming from the direction of 3I Atlas, a signal that repeats every 3 minutes and 47 seconds. The same interval, with phase modulation that natural hydrogen masers don't produce. 3 days later, MeerKAT, the South African radio telescope array, independently detected the same pattern. They weren't looking for it. They were conducting unrelated observations of the galactic center when the signal appeared in their data. Contamination from a source that shouldn't be active, background noise from coordinates that matched 3I Atlas's trajectory. 2 independent observatories, same frequency, same pattern, same 3-minute 47-second repetition. And then the silence began. Not the silence of empty space, but the silence of institutions that know something and aren't ready to talk about it. SETI hasn't released a statement. Green Bank's observation logs for November 12th haven't been published in any public database. MeerKAT's data from that week remains embargoed under routine processing protocols that somehow keep getting extended. NASA, when asked by journalists about reports of radio signals from 3I Atlas, redirects questions to ongoing analysis. ESA won't comment. The International Astronomical Union, which typically coordinates announcements of significant observations, has said nothing. And that silence, that careful institutional quiet, feels exactly like what happened in October when 3I Atlas made its closest approach to Mars and 5 space agencies with cameras pointed directly at it released nothing. No images, no data, no acknowledgement that anything unusual occurred. Just silence while the internet filled with speculation. And amateur astronomers tried to make sense of stacked Perseverance navcam frames that showed an elongated blur where the most anticipated interstellar observation in history should have been crystal clear. Now we have a signal, unconfirmed officially, undeniable in the data streams that amateur radio astronomers are analyzing, in the chatter on encrypted astronomy Discord servers, in the sudden spike of deleted posts on academic Twitter when people realize they've said too much. A signal at the universal frequency from an object that has violated every expectation we had about what interstellar visitors should look like. And the question that nobody with institutional authority wants to ask out loud is becoming impossible to ignore. Is 3i Atlas transmitting? Before we go deeper into what this signal might mean, if it's real, if it's confirmed, if it represents what some researchers are starting to believe it represents, we need to understand what 3i Atlas already is. Because the signal, if true, isn't the first impossibility. It's the latest in a sequence of violations, a pattern of anomalies that has been building since July, accumulating week by week, observation by observation, until the object stopped looking like an unusual comet and started looking like something we don't have a category for. If you're hearing about 3i Atlas for the first time, if you've been following other news and missed the slow drumbeat of strangeness that has been emanating from astronomical journals and Avi Loeb's blog posts and amateur astrophotography forums for the past 4 months, let me bring you up to speed. Because the signal makes sense, or at least the possibility of a signal makes sense, only when you understand everything else that's already wrong. 3i stands for interstellar, the third confirmed object from beyond our solar system. The first was 1i Oumuamua, discovered in October 2017, a pancake or cigar-shaped visitor that accelerated away from the sun in ways that pure gravity couldn't explain. The second was 2i Borisov, discovered in August 2019, a relatively normal-looking comet that behaved exactly as comets should, outgassing water vapor, developing a proper tail, following predictable trajectories. It was almost boring in its normalcy, which was reassuring. Interstellar objects could be strange, Oumuamua proved that, but they could also be mundane. Borisov suggested that most of what drifts between the stars is just rocks and ice, debris from distant planetary systems, nothing that challenges our understanding. And then came 3i Atlas, discovered July 1st, 2025 by the Atlas Survey Telescope in Hawaii, initially designated as a potential comet based on its fuzzy appearance, quickly confirmed as interstellar, when orbit calculations showed a hyperbolic trajectory with eccentricity above 6. It was moving at 60 kilometers per second relative to the Sun, far above escape velocity, coming from the direction of Sagittarius, from the thick disk region of the galaxy. And it was bright. Too bright. Comets at that distance beyond Jupiter's orbit are usually frozen and inert. They don't start outgassing until they get much closer to the Sun, usually inside Mars' orbit, where solar radiation becomes intense enough to sublimate surface ice. But 3i Atlas was glowing when it shouldn't be, active when it should be dormant, producing a visible coma of gas and dust at a distance where temperature and solar flux couldn't explain that level of activity. That was the first oddity. Not impossible, not a violation of physics, but unusual. A comet that starts early. Then came the size estimates. When astronomers measure how big a distant object is, they calculate backward from brightness. You observe how much sunlight it reflects, you estimate how reflective its surface probably is, that's called albedo, and you derive a diameter. For 3i Atlas, those initial calculations kept producing the same answer. 20 kilometers. 20 kilometers in diameter. Bigger than Manhattan Island. Twice the size of the asteroid that ended the dinosaurs. For an interstellar object, that's statistically absurd. Large objects are rare. The distribution of debris in space follows a power law. For every mountain-sized rock, there are millions of pebbles. We should have catalogued tens of thousands of Oumuamua-scale visitors, those 100-meter objects, before ever spotting something as massive as a 20-kilometer comet. But we'd only found 2 interstellar objects before Atlas, just 2. And now here was something potentially 1,000 times more massive than either of them. The statistics didn't work. Avi Loeb calculated that finding an object this large, this early, meant either our models of interstellar object populations were wrong by factors of 10,000, or 3i Atlas represented something other than random debris. Then the observations got better. Hubble Space Telescope imaged it on July 21st. The pictures showed something strange. A teardrop-shaped cocoon of dust with brightness extending ahead of the nucleus toward the Sun, not behind it. Comet tails point away from the sun, always. Radiation pressure and solar wind push gas and dust outward. The tail streams behind like hair in the wind, anti-solar by definition. But 3I Atlas had a forward glow, an extension of scattered light pointing sunward, like headlights instead of a tail. NASA scientists explained it as motion blur, an artifact of how Hubble tracked the fast-moving object during exposure, maybe. But the extension was 10 times longer in the solar direction than perpendicular. Even accounting for viewing geometry and smearing effects, that asymmetry was hard to explain. And then by late August, when Gemini South Telescope imaged it again, a proper tail had developed. Normal orientation streaming away from the sun, exactly where it should be. So between July and August, something changed. Either the viewing angle shifted enough to reveal what was always there, or the object started behaving more like a normal comet as solar heating increased. Take your pick. Both explanations work, sort of, if you don't look too closely at the details. The James Webb Space Telescope observed 3I Atlas on August 6th using its near-infrared spectrograph. Webb doesn't take pictures the way Hubble does. It analyzes light, breaking it down into component wavelengths, revealing the chemical composition of whatever it's observing. When Webb looked at the gas cloud surrounding 3I Atlas, the coma, it found something that stopped researchers cold. The gas was 87% carbon dioxide, 9% carbon monoxide, and only 4% water. That's an 8-to-1 ratio of carbon dioxide to water, among the highest ever recorded for any comet, natural or otherwise. Comets are supposed to be water-rich. Every comet we've studied from our solar system, every sample returned, every spectroscopic analysis, they're dominated by water ice. Carbon dioxide is there, sure, but as a minor component. Water is the primary volatile, the stuff that sublimates and creates the coma and drives cometary activity. But 3I Atlas is a dry comet. It's made of carbon dioxide ice with barely any water, like it formed in an environment so cold that water was depleted while carbon dioxide remained, or like it's been processed, baked, altered by billions of years of cosmic ray exposure during its journey through interstellar space. Except cosmic rays don't selectively remove water while leaving carbon dioxide. The chemistry doesn't work that way. The ratio is backwards, inside out, and nobody has a fully satisfying natural explanation for it. Then came the very large telescope observations from Chile. The VLT used its ultraviolet spectrograph to look for metal emissions, atoms of iron, nickel, sodium, calcium, the kind of trace elements that appear in cometary comas when rocky material gets heated and vaporizes. And they found nickel. Strong emission lines at multiple wavelengths, clear and unambiguous. Nickel atoms streaming off the surface, glowing under ultraviolet excitation from the sun. But there was almost no iron. In nature, nickel and iron are inseparable. They're forged together in the cores of dying stars, expelled together in supernovae, incorporated together into planets and asteroids and comets. Every rock we've ever analyzed shows them in consistent ratios. They're chemical twins. Finding nickel without iron is like finding smoke without fire. It doesn't happen naturally. Except in industrial processes. On Earth, we separate nickel from iron when we want high-purity nickel for specialized applications. Aerospace alloys, battery components, corrosion-resistant coatings. We use chemical refinement, electrochemical processes, techniques that don't exist in nature, and the signature we're seeing from 3I Atlas, nickel emission with suppressed iron, matches industrial production, not cosmic abundance. The VLT team tried to explain it. They suggested maybe nickel carbonyl, an exotic organometallic compound, was forming on the surface and sublimating while iron compounds remained stable. Possible, maybe, if conditions were exactly right, if the chemistry was perfectly balanced, if a dozen variables all aligned. But nickel carbonyl is a synthetic compound. We make it in labs. It's used in the MON process for nickel purification. Patented in the 1890s, how does a synthetic industrial chemical appear on a rock that's supposedly billions of years old, formed in the protoplanetary disk of some distant star system, untouched by technological processes? There's no good answer. Just uncomfortable silence and papers that use phrases like extremely puzzling and unprecedented observations and require further study. And the nickel production wasn't stable. It increased as 3I Atlas approached the Sun, but not gradually. The emission rate jumped 25-fold between late July and late August. 25 times more nickel streaming off the surface in just 1 month. The increase followed a steep power law, scaling with solar distance to the power of -8 or -9, far steeper than normal thermal sublimation. It looked less like ice passively melting and more like something being systematically vaporized, processed, activated by increasing energy input. Then there was the color change. In July and early August, 3I Atlas appeared reddish in color images, typical for a comet at that distance, indicating dust particles and organic compounds reflecting sunlight with a bias toward longer wavelengths. But on September 7th, during a total lunar eclipse, 2 experienced astrophotographers in Namibia captured images that showed something different. 3I Atlas was glowing green. Vivid, emerald green, unmistakable, the kind of color that comes from diatomic carbon molecules fluorescing under ultraviolet light. Green comets are common. C2, 2 carbon atoms bonded together, absorbs UV and re-emits visible light at 5-10 nanometers, right in the green part of the spectrum. Except spectroscopic analysis from Kitt Peak Observatory in early August had shown that 3I Atlas was among the most carbon chain depleted comets ever observed. It had very low concentrations of C2, the exact molecule responsible for green color. So how does a comet with almost no diatomic carbon suddenly glow bright green? One explanation is that C2 was buried beneath the surface and got exposed as deeper ice layers sublimated. Another is that the color comes from something else, maybe cyanide, which can also produce greenish hues and which the VLT detected in rapidly increasing quantities. Or maybe the color change represents an activation, a threshold effect, something turning on as solar heating crossed a critical temperature. The transformation was sudden, not gradual, like flipping a switch. Red one week, green the next. Now here's where the physics breaks completely. A team led by Richard Clough and Avi Loeb analyzed 4,022 positional observations of 3I Atlas from 227 observatories worldwide between May and September. They tracked the object's movement with extreme precision, comparing its actual trajectory to what pure gravity would predict. Comets experience something called non-gravitational acceleration. When they outgas, when ice turns to vapor and jets into space, that creates thrust. It's tiny but measurable. The gas pushes the comet slightly off course, creating deviations from a purely gravitational path. Every active comet shows this. It's one of their defining characteristics. You can measure the size of the deviation and work backwards to estimate how much thrust the outgassing produces, which tells you about the comet's mass and activity level. 3I Atlas, according to the analysis, shows almost no non-gravitational acceleration. The upper limit is less than 15 meters per day squared. That's virtually nothing. And yet the James Webb Telescope measured the mass loss rate at approximately 150 kilograms per second. That's a lot of gas. That's enough material ejecting at high velocity to produce significant thrust to push the comet detectably to create acceleration that should be obvious in the trajectory data. But it's not there. The object moves like it's only feeling gravity, like the outgassing doesn't affect it at all. The only way that works is if 3I Atlas is incredibly massive. If it weighs so much that 150 kilograms per second of thrust is negligible, like trying to push a cruise ship with a leaf blower. The force is there, but the mass is so large that the acceleration is below detection limits. So they calculated the minimum mass required. Given the observed outgassing rate and the absence of detectable thrust, how heavy does 3I Atlas have to be? The answer they got was 33 billion tons. 33 billion tons as a lower bound, possibly much more depending on uncertainties in the outgassing vector and mass loss distribution. That mass, combined with density assumptions for ice and rock, gives you a diameter of at least 5 kilometers, maybe significantly more. So we're back to a large object. Not 20 kilometers? Probably not, but definitely on the high end. Definitely more massive than any other interstellar visitor we've seen. 3 to 5 orders of magnitude heavier than Oumuamua or Borisov, 1,000 to 100,000 times more mass. And the statistical problem returns. Finding something this massive this early in our survey of interstellar objects is, in Avi Loeb's words, a major anomaly requiring explanation. It's like flipping a coin and getting heads 1,000 times in a row. Technically possible, vanishingly unlikely. Then there's the polarization data. When light reflects off dust particles, it becomes polarized. The degree and direction of polarization tells you about the size, shape, and texture of those particles. Every comet and asteroid ever studied falls within predictable ranges. The polarization signatures are consistent, well understood, catalogued across decades of observations. 3I Atlas doesn't fit. Measurements showed negative polarization of -2.77% at a phase angle around 7 degrees. That combination has never been observed in any solar system object. Never. The only way to produce those numbers is if the dust grains are fundamentally different. Not normal silicate sand, not water ice crystals, something else. Large, complex particles, highly porous, irregular structures with huge surface area to volume ratios. Almost like soot, like manufactured aerosol, like the kind of dust you get from combustion or chemical vapor deposition, not from ice sublimating and lifting rocky grains off a comet's surface. The research team that measured this initially thought their instruments were malfunctioning. They recalibrated. They repeated the observations. Same result. The dust around 3I Atlas has properties that don't match natural comet dust. And then there's the trajectory itself, the path this object is following through our solar system, because the geometry is just as strange as the chemistry. 3I Atlas entered the solar system on a retrograde orbit, inclined at about 175 degrees to the ecliptic plane. That sounds extreme, but what it means is the object is moving almost exactly in the plane where the planets orbit, just backwards. It's aligned with the ecliptic to within 5 degrees. The probability of that happening randomly if interstellar objects arrive from arbitrary directions in 3-dimensional space is about 1 in 500. Not impossible, rare. But it's not just the alignment. The trajectory brings 3I Atlas close to multiple planets. It passed within 29 million kilometers of Mars on October 3rd. It made relatively close approaches to Venus earlier in its inbound journey, and it's positioned for a moderately close encounter with Jupiter in March 2026. The combined probability of all 3 planetary encounters happening by chance, accounting for orbital timing and positions, is about 1 in 20,000. And the trajectory isn't just geometrically convenient. The timing is perfect. 3I Atlas arrived in the inner solar system when the planets were in positions that allowed those close approaches. If it had arrived a few months earlier or later, the encounters wouldn't have happened. Mars would have been on the wrong side of its orbit. Venus would have been elsewhere. The synchronization of arrival time with planetary positions is another low probability event stacked on top of all the others. And then there's the perihelion timing. 3I Atlas reached its closest point to the Sun on October 29, 2025, at a distance of 1.36 astronomical units, just inside Mars' orbit. And on that date, Earth was on the exact opposite side of the Sun. Solar conjunction. The object was hidden from every telescope on Earth, obscured by the Sun's glare, unobservable. If you were designing a trajectory that allowed you to pass through perihelion, The point of maximum solar heating and maximum orbital velocity, without being watched by the most technologically advanced planet in the system, you'd arrive at perihelion during solar conjunction. You time it so the planet with all the telescopes is on the far side of the star. That's what happened. The probability of perihelion occurring during solar conjunction, if arrival time is random, is about 1 in 20. Another coincidence. Another roll of the dice that came up with an improbable result. Avi Loeb has been cataloguing these anomalies, listing them, calculating their combined probability, and arguing that at some point you stop accepting coincidence as an explanation and start considering alternatives. He's rated 3I Atlas at 6 out of 10 on what he calls the Loeb scale, a framework for assessing how likely an interstellar object is to be technological rather than natural. 6 out of 10. That's 60% confidence that this isn't a random chunk of ice and rock. 60% confidence that we're looking at something designed. Most of the astronomical community thinks he's wrong. They think the anomalies have natural explanations that we just haven't figured out yet. They think calling it alien technology is premature, sensationalist, bad science. They point to the tail that eventually developed, to the outgassing that matches cometary behavior, to the fact that unusual chemistry doesn't equal artificial origin. And they're probably right. The most likely outcome is still that 3I Atlas is a comet, an extremely unusual comet from an environment we don't understand, exhibiting properties we haven't seen before, but ultimately natural. Formed billions of years ago in some distant star system and ejected into interstellar space by gravitational interactions during planet formation. Just another piece of cosmic debris on a trajectory that happened, by extraordinary luck, to bring it through our neighborhood. That's the conservative position, the safe bet. The explanation that doesn't require invoking extraterrestrial intelligence or interstellar probes or technology beyond our comprehension. And then on October 3rd, when 3I Atlas made its closest approach to Mars and 5 space agencies with spacecraft in perfect position to image it released nothing, that conservative position started feeling less safe. Let's talk about what happened during the Mars flyby, because this is where institutional behavior becomes part of the mystery. NASA's Mars Reconnaissance Orbiter has a camera called HiRISE, the High Resolution Imaging Science Experiment. It's designed to photograph the Martian surface with incredible detail, resolving features down to about 30 centimeters from orbit. When pointed at 3I Atlas from a distance of 29 million kilometers, HiRISE should achieve resolution of roughly 30 kilometers per pixel. That's not enough to see surface details, but it's more than enough to separate the nucleus from the surrounding coma, to measure the actual size of the solid core, to confirm whether the object really is 5 kilometers across or larger. HiRISE was scheduled to observe 3I Atlas on October 3rd. Mission planners had months of advance notice. The geometry was perfect. This was the closest any human spacecraft would get to an interstellar object, potentially ever, certainly for decades. It was the observation opportunity of a generation, and NASA furloughed 15,000 employees on October 1st. The US government entered a shutdown because of budget negotiations. Thousands of NASA staff were sent home. Operations continued with skeleton crews focused on mission-critical activities. Processing and releasing images of an interstellar comet apparently didn't qualify as mission-critical. The Mars Reconnaissance Orbiter kept functioning. The camera kept working. Data was collected and transmitted back to Earth through normal channels. But nothing was released. No images, no press release, no preliminary findings, just silence. And it wasn't just NASA. The European Space Agency operates 2 spacecraft at Mars, Mars Express and the ExoMars Trace Gas Orbiter. Both have high-resolution cameras and spectrometers. Both were positioned to observe 3I Atlas. ESA announced in September that observations would take place between October 1st and 7th. They specified which instruments would be used. They described the scientific objectives. And then after the flyby, nothing. No data release, no images. No acknowledgement beyond a brief statement confirming that observations had occurred and data was being analyzed. China's Tianwen-1 mission includes an orbiter with cameras that regularly image Mars and occasionally photograph other objects in the Martian sky. China has been extraordinarily public with their Mars mission, releasing thousands of images, celebrating their technological achievements, using the mission for soft power and international prestige. During the week of October 3rd, Tianwen-1 went quiet. No image releases, no updates on social media, no press conferences celebrating their observations of the historic interstellar flyby. The United Arab Emirates operates the HOPE probe, designed to study the Martian atmosphere using spectrometers perfect for analyzing the gas emissions from a comet. HOPE has been a source of pride for the UAE, their first interplanetary mission, regularly featured in national media. They announced before the flyby that HOPE would observe 3I Atlas. And then, after October 3rd, silence. 5 space agencies, 3 continents, geopolitical rivals, nations that compete for prestige and funding and international recognition, all of them with functioning spacecraft, all positioned to observe the same event, and all of them choosing not to share what they saw. The official explanation from NASA was the government shutdown. Furloughed staff, minimal operations, data processing delayed. Fair enough. Government shutdowns happen. They disrupt workflows. But the shutdown didn't stop the Perseverance rover from automatically uploading raw NavCam images. Those images, low-resolution black and white frames from the rover's navigation cameras, continued posting to public servers throughout the shutdown because the process is automated. If raw NavCam data could upload during a shutdown, why couldn't raw high-rise data? Why couldn't ESA, operating independently of American budget politics, release their Mars Express images? Why did China, which had been publishing Tianwen-1 images weekly, suddenly stop during that specific week? Why did the UAE, eager to showcase their mission's capabilities, go silent? The pattern looks less like bureaucratic delay and more like coordination. Not conspiracy necessarily, but protocol. Like there's an understanding among space agencies that certain observations require careful handling, verification, interagency consultation before public release. Which raises the question, what did they see? An anonymous post appeared on 4chan's paranormal board on October 1st. The poster claimed to be a PhD researcher working with the European Space Agency, part of a working group analyzing 3I Atlas data. The post was detailed, technical, frustrated. It described months of effort trying to reconcile the object's behavior with any known class of natural body. It talked about chemistry that didn't make sense, physics that violated expectations, institutional pressure to maintain the official position that 3I Atlas is a comet, despite data that increasingly contradicted that classification. The post mentioned the nickel without iron, the extreme carbon dioxide ratio, the polarization anomaly, the lack of non-gravitational acceleration despite violent outgassing. It described these as a self-consistent system of wrongness, as though the object's whole purpose is to make us doubt ourselves. And it suggested that the silence from leadership was becoming a serious professional issue for a growing number of researchers who couldn't reconcile what they were seeing with what they were being told to conclude. Now, anonymous posts on 4chan are not peer-reviewed science. They're not verified. They could be elaborate fiction, creative writing exercises, someone who read the scientific papers and decided to stir up speculation. But the level of technical detail was unusual. Frustration felt genuine, and the claims aligned disturbingly well with the public data, while adding context that hadn't appeared in any official release. The post described internal debates about whether to release the Mars flyby images at all, concern that the public reaction might be disproportionate, discussion about verification processes and chain of custody for data that might have implications beyond science. It painted a picture of institutions that saw something unexpected and aren't sure how to handle it. Whether that post was real or not, whether it represented genuine insider frustration or skilled storytelling, it captured something true about the situation. There's a gap between what scientists are saying privately and what's being stated publicly. There's data that hasn't been released. There are observations that should have been straightforward, but somehow require months of analysis before anything can be shared. And that gap, that hesitation, feeds speculation. In the absence of official information, people fill the void with theories. Some of those theories are wild, disconnected from evidence, driven by wishful thinking or paranoia. But some are careful, methodical, grounded in the same data that professional astronomers are analyzing, and they ask questions that deserve answers. Questions like, if 3I Atlas is just an unusual but ultimately natural comet, why the institutional silence? Why the coordinated non-release of data across multiple agencies? Why did the most significant close-range observation of an interstellar object in human history produce no public images, no preliminary findings, not even a confirmation that the observations were successful? And now allegedly we have a signal. Reports began circulating in mid-November through amateur radio astronomy networks and closed academic channels. The claims were specific. Green Bank Telescope, November 12, 3:47 a.m. GMT. Routine observations of the region where 3I Atlas had disappeared behind the Sun detected a radio emission at 1420-4256 megahertz. The emission repeated every 3 minutes and 47 seconds with phase modulation characteristics inconsistent with natural hydrogen mass sources. 3 days later, MeerKAT in South Africa independently detected the same pattern during unrelated observations. Same frequency, same repetition interval, same coordinates matching 3I Atlas's trajectory. The reports are unconfirmed. There's no official announcement from Green Bank or MeerKAT. There's no SETI Institute press release. There's no NASA statement, but the chatter is real. Amateur radio astronomers are discussing it. Academic Twitter had a brief flurry of posts before people started deleting things. Astronomy Discord servers are analyzing data files that may or may not be legitimate, and the pattern of institutional silence is repeating. No confirmation, no denial, just quiet while the speculation builds. Let's talk about what a signal at 1420 megahertz would mean, because this isn't arbitrary. This is the frequency that SETI researchers have been monitoring for decades, the wavelength where we've been listening for messages from other civilizations, the universal calling card. Hydrogen is the simplest atom, one proton, one electron. When the electron flips its spin state, the atom emits a photon at exactly 1420.4256 megahertz. This emission is called the hydrogen line or the 21 centimeter line, and it's one of the most important frequencies in all of astronomy. Radio telescopes use it to map hydrogen gas in galaxies. It's how we traced the spiral arms of the Milky Way. It's how we measure the rotation of distant galaxies. It's fundamental to our understanding of the universe's structure, and it's also the frequency that every technological civilization would know about because hydrogen is everywhere. Any species that develops radio astronomy will discover the hydrogen line. It's a universal constant, the same everywhere in the cosmos. So if you wanted to send a signal that another civilization would recognize as artificial, you'd broadcast at 1420 megahertz. It's the obvious choice, the first place anyone would look. Frank Drake, one of the pioneers of SETI, called it the cosmic watering hole, the frequency where intelligences might gather to exchange information. When the Voyager spacecraft were launched in 1977, they carried golden records with instructions on how to play them and where Earth is located in the galaxy. Those instructions assumed the finders would understand the hydrogen line frequency as a universal reference. When the Arecibo message was transmitted in 1974, a demonstration of humanity's ability to send interstellar messages, it was broadcast at a frequency near the hydrogen line. When SETI researchers design their search strategies, they prioritize 1420 MHz and frequencies nearby. It's been monitored continuously for decades through Project Phoenix, through Breakthrough Listen, through countless smaller surveys. And in all that time, in all those decades of listening, we've detected exactly one signal that made us stop and question whether it might be artificial: the WOW signal. August 15th, 1977, Big Ear Radio Telescope in Ohio, a narrowband signal at 1420.4 MHz that lasted 72 seconds, the exact duration you'd expect if the signal was coming from a point source and the telescope's beams swept across it as Earth rotated. The signal was strong, 30 times louder than background noise. Astronomer Jerry Amon saw the data printout and wrote "wow" in the margins because the pattern was so striking, so obviously different from anything natural. They've been looking for it ever since. Decades of follow-up observations. The Big Ear telescope pointed at the same spot in the sky hundreds of times. Other telescopes joined the search. Nothing. The signal never repeated. It came once and vanished, leaving us with a mystery that still hasn't been solved almost 50 years later. The generally accepted explanation now is that it was a natural phenomenon, maybe a passing comet releasing hydrogen gas that briefly reflected a terrestrial signal back toward Earth. Boring, but plausible. The alternative, that it was a genuine extraterrestrial transmission, requires evidence we don't have. One signal isn't enough. You need repetition, structure, information content, something that distinguishes it from a statistical fluke. But the WOW signal came from a direction in the constellation Sagittarius. And when you trace 3I Atlas's trajectory backward through the galaxy, accounting for its velocity and direction, calculating where it would have been in 1977, you get an answer. Within 9 degrees of the WOW signal's origin. 9 degrees? Not the exact same spot, but nearby within the same general region of sky. The probability of that alignment is roughly 1 in 150. Another coincidence? Another unlikely thing in a long list of unlikely things. Avi Loeb has written about this connection, suggesting that if 3I Atlas is artificial, if it's a probe from another civilization, maybe it sent an announcement signal in 1977 when it was still far from our solar system. A "hello, we're approaching" message broadcast at the universal frequency so anyone listening would hear it. Then the probe went silent, coasting inward, looking like a natural object until it got close enough to begin its mission, whatever that mission might be. It's speculative. It's built on a foundation of ifs and maybes, but the geometry is real. The trajectory alignment with the WOW signal origin is documentable. It exists independent of interpretation. And now allegedly there's a new signal. Not a brief burst like the WOW signal, but a repeating pattern. Every 3 minutes and 47 seconds. If the reports are true, if the data is legitimate, if Greenbank and MeerKAT really did detect this, then we're not looking at a one-time anomaly that could be dismissed as interference or instrumental artifact. We're looking at a clock, a repeating transmission, something that says I am here with regularity. 3 minutes and 47 seconds is an interesting interval. It's not a round number in any human time system, not 5 minutes or 3 minutes or anything that would suggest terrestrial interference. But it is close to the rotational period you'd expect for an object a few kilometers across, spinning at a moderate rate. If 3I Atlas is rotating once every 3.8 minutes or so, and if there's a directional antenna or a surface feature that emits radio waves preferentially in one direction, then observers would detect a pulse every time that feature rotated toward them. Like a lighthouse, the beam sweeps around. You see a flash, darkness, another flash, darkness, regular as clockwork. Natural objects can produce periodic radio emissions. Pulsars do this, rotating neutron stars with magnetic fields so intense they create beams of radio waves that sweep across space like cosmic lighthouses. But pulsars pulse much faster, typically once per second or even milliseconds. And their emission mechanism is well understood, driven by extreme physics in the collapsed remnant of a dead star. 3I Atlas isn't a neutron star. It's a few kilometers across with a mass measured in billions of tons, not solar masses. It doesn't have the magnetic field strength or rotational energy to power pulsar-like emission. So if it's transmitting radio waves, the mechanism has to be something else. Natural hydrogen masers are another possibility. Under specific conditions, clouds of hydrogen gas can act like cosmic lasers, amplifying radio waves at the hydrogen line frequency through stimulated emission. You need a population inversion, more hydrogen atoms in the excited spin state than the ground state, and you need a pumping mechanism, some energy source that maintains that population inversion. Around comets, the energy source could be ultraviolet light from the sun exciting hydrogen atoms in the coma. If the geometry is right, if the gas cloud has the right density and temperature, it can produce coherent radio emission at 1420 MHz. Naturally, no technology required. This is the most likely explanation for a signal from 3I Atlas if a signal exists. The object is outgassing. Webb measured 150 kilograms per second. That gas includes hydrogen, both from water molecules that break apart and from other hydrogen-bearing compounds. Solar UV hits that hydrogen, excites it, and under the right conditions you get maser emission. The emission could be periodic if the outgassing is asymmetric, if there's a jet on the nucleus that rotates in and out of view, creating pulses as the hydrogen cloud brightens and fades with the rotation. This works. The physics is sound. Comets have produced hydrogen maser emission before, though it's rare and usually weak. But there's a problem with this explanation, and it has to do with the phase modulation. Radio waves have properties beyond just frequency and intensity. They have phase, a measure of where the wave is in its oscillation cycle at any given moment. Natural sources like masers produce emission with random or slowly varying phase. The phase relationship between successive pulses is unpredictable because the emission is driven by incoherent quantum processes, millions of atoms emitting independently without coordination. Artificial sources, transmitters, produce emission with controlled phase. You can modulate the phase deliberately, encoding information by shifting the wave's oscillation in specific patterns. It's how modern digital radio communication works. Phase shift keying, quadrature amplitude modulation, techniques that pack data into radio signals by manipulating phase relationships. According to the unconfirmed reports circulating through amateur networks, the signal detected from 3I Atlas shows phase modulation. Not random phase variations, but structured patterns. The phase shifts in ways that don't match natural hydrogen maser emission. It looks designed. This is where most astronomers would stop and say, "Show me the data." Extraordinary claims require extraordinary evidence, and right now, all we have are rumors and anonymous reports and deleted Twitter posts. No peer-reviewed paper, no official confirmation, no independent verification from multiple observatories with full data transparency. Just whispers and speculation and the same institutional silence that characterize the Mars flyby. But let's assume for a moment that the reports are true. Let's follow the logic. If 3I Atlas is transmitting a structured phase-modulated signal at the hydrogen line frequency, repeating every 3 minutes and 47 seconds, then the natural explanations stop working. Masers don't produce phase-modulated signals. Solar interference doesn't repeat with that kind of regularity. Background noise doesn't have structure. You're left with either an unknown natural phenomenon, some exotic plasma physics we've never observed before that just happens to produce patterns that look artificial, or you're looking at technology, a transmitter, a beacon, something broadcasting deliberately. And the question becomes why? Why would an object that has spent months looking like a comet, outgassing and developing a tail and exhibiting chemical properties that are weird but not impossible, suddenly start transmitting radio signals? One answer is activation. If 3I Atlas is a probe, if it's been dormant during its long journey through interstellar space, it would need to wake up when it reached its destination. Temperature would be an obvious trigger. As it approached the sun and surface temperatures rose, systems could power on, instruments could initialize, and at some point it would begin its programmed mission, whatever that is. Perihelion would be the logical activation point. That's when solar heating is at maximum, when the object has the most energy available if it's using solar power. And perihelion occurred on October 29th, exactly 2 weeks before the alleged signal detection. The timeline fits. Object reaches perihelion behind the sun where Earth can't observe it. Systems activate. 2 weeks later, it begins transmitting. Another possibility is that the signal isn't meant for us. If 3i Atlas is a probe reporting back to whoever sent it, the transmission could be pointed in a completely different direction, aimed at a distant star system light years away. We might be detecting spillover side lobes from a directional antenna that's primarily broadcasting elsewhere. In that case, the fact that we can detect it at all might be accidental. The probe isn't trying to communicate with us. We just happen to be close enough to pick up a signal that's meant for someone else. Or the signal could be a standard beacon, an automated transmission that says, this probe is functional and operating. Spacecraft we send to other planets do this constantly. They transmit telemetry, status updates, confirming that systems are working and missions are proceeding as planned. If 3i Atlas is a probe, it might have a similar protocol. Reach perihelion, activate, begin transmitting status updates to confirm successful arrival. The transmission might not contain any message for us. It might just be a carrier wave, a tone that says, I'm here, I'm alive, I'm functioning. But there's a darker interpretation, one that people don't want to say out loud, but that hovers over every conversation about this. What if the signal is a warning? What if 3i Atlas detected technological signatures from Earth, radio emissions, artificial lights, atmospheric pollution, signs of industrial civilization, and transmitted that information forward? The probe itself might be ancient, might have been traveling for millions of years at sublight speeds. But if it has faster-than-light communication, quantum entanglement, or something we don't understand, it could send data instantaneously across interstellar distances. In that scenario, the signal we're detecting might not be the main transmission. It might be a local broadcast, a notification to anything in this solar system that a report has been filed, that Earth's location and technological status has been shared with whoever or whatever sent the probe. This is the dark forest hypothesis, the idea that the universe is full of civilizations but they all stay silent because revealing your presence is dangerous. If you don't know the intentions of other species, if you can't be sure they're peaceful, the safest strategy is to stay hidden. And if you're an aggressive civilization, if you're expanding and consuming resources and eliminating competition, you send probes to find emerging civilizations and report their locations so they can be dealt with before they become threats. Avi Loeb has referenced this scenario in his writings, not as a prediction, but as a possibility that shouldn't be dismissed without evidence. If 3i Atlas is artificial, he says, it could come to save us or destroy us, and we should be prepared for both possibilities. The signal, if real, doesn't tell us which. A repeating transmission at the universal frequency could be an invitation to communicate, or it could be a countdown. The only way to know is to analyze the signal, decode any information it might contain, and prepare for whatever comes next. But we can't analyze what we can't access. If Green Bank detected this signal, the data exists somewhere in their archives. If MeerKAT confirmed it, their records would show the same pattern. But radio telescope data is often embargoed for months or years while research teams analyze it and prepare publications. Observations become public eventually, but the delay can be substantial, especially if the findings are unexpected or controversial. SETI has protocols for what to do if a candidate signal is detected. The first step is verification. Confirm it's real, not instrumental artifact or terrestrial interference. Confirm it's coming from space, not from a satellite or aircraft or ground-based transmitter. Confirm it repeats that it's not a one-time statistical fluke. Only after verification, after multiple independent observatories detect the same signal and rule out all prosaic explanations, does SETI issue a public announcement. The process is deliberately slow, designed to prevent false alarms, to ensure that when they say we found something, they're certain. The 1997 SETI post-detection protocols, developed after the WOW signal and other false alarms, specify that no public announcement should be made until the detection is confirmed and verified by independent parties. The protocols also state that the discovery should be reported to international authorities, to the United Nations, to the scientific community through proper channels before going to the press.
This is rational.
This prevents panic and misinformation, but it also means that if a signal was detected in mid-November, we might not hear official confirmation for months. We might not know until well into 2026, after every possible natural explanation has been exhausted, after multiple observatories confirm the finding, after committees meet and reports are written and press releases are drafted. Meanwhile, the object continues moving. 3i Atlas is currently behind the Sun from Earth's perspective, but that won't last forever. In early December, it will emerge from solar conjunction and become visible again from Earth-based telescopes. That's the critical observation window. When it reappears, astronomers will measure its position precisely and recalculate its trajectory. If the orbit is unchanged from predictions, if it's still on a hyperbolic escape path heading out of the solar system, then nothing happened at perihelion. No maneuver, no course correction, just a natural object following gravitational laws. But if the orbit has changed, if there are deviations that can't be explained by outgassing or gravitational perturbations from planets, that would be evidence of propulsion. Evidence that something adjusted the trajectory deliberately. Avi Loeb has specified November 21st through December 5th as the detection window for trajectory changes. If a maneuver occurred at perihelion on October 29th, the effects would become measurable by late November. The object's position would deviate from predictions by amounts that grow larger over time, as the new trajectory diverges from the old. By early December, the deviation would be unambiguous if it exists, so we're in a waiting period. The alleged signal detection in mid-November, the December reappearance when trajectory can be verified, the slow process of data analysis and peer review that will eventually confirm or refute the signal reports. And during this waiting period, the speculation intensifies because nature abhors a vacuum, and so does human curiosity. Let's talk about what we're actually dealing with here, assuming the worst case or best case depending on your perspective.
Assuming 3i Atlas is artificial.
What would that mean? What are we looking at? The most conservative technological hypothesis is that it's a derelict, an ancient spacecraft that failed long ago and has been drifting dead through the galaxy for millions or billions of years. In that scenario, it wouldn't be functional. It wouldn't be transmitting signals or maneuvering. It would just be wreckage, an archaeological artifact from a civilization that might not even exist anymore. The strange chemistry, the nickel without iron, the unusual dust, those could be decay products from technological materials breaking down over geological timescales. The lack of non-gravitational acceleration despite outgassing could be explained if the object is hollow, if it's a shell or framework that used to contain machinery but now is just a massive inert structure collecting ice as it passes through interstellar gas clouds. This interpretation has the advantage of explaining the anomalies without requiring ongoing intelligence or activity. You get weird chemistry from ancient technology eroding. You get high mass with unusual behavior because the structure isn't a natural comet. But you don't get signals because there's nothing alive or functional to generate them. Except the signal reports, if true, contradict this.
A derelict doesn't transmit.
Dead spacecraft don't broadcast at the hydrogen line frequency with phase modulation and regular repetition. If the signal is real, the object is functional. Which brings us to the active probe hypothesis, a spacecraft sent by another civilization to explore nearby star systems, still operational after however many millions of years it's been traveling, designed to survey planets and moons and assess whether they harbor life or resources or threats. This is actually not as far-fetched as it sounds. We've sent probes beyond our solar system.
Voyager 1 and 2 pioneer 10 and 11 new horizons.
They're all on trajectories that will take them into interstellar space. Voyager 1 crossed into interstellar space in 2012, and it's still functioning, still transmitting data back to Earth after more than 45 years. The radioisotope thermoelectric generators that power it will last maybe another decade before decaying below useful output, but the spacecraft itself could drift for millions of years. If we wanted to design a probe that could last longer, that could operate for geological timescales, we'd use different power sources. Solar panels that could be unfurled near stars to recharge batteries or capacitors. Nuclear reactors with fuel that has half-lives in the billions of years. Energy harvesting from cosmic rays or from the interstellar medium itself as the probe moves through diffuse gas. An advanced civilization would have options we haven't thought of. And if you're sending a probe on a journey that might last millions of years, you'd design it to be self-repairing, to carry raw materials and manufacturing capability to replace damaged components. You'd give it artificial intelligence sophisticated enough to handle unexpected situations, to adapt to environments you couldn't predict when you launched it. You'd make it autonomous because communication delays across interstellar distances make remote control impossible. So we'd be looking at a machine intelligence, something that makes its own decisions based on programming that could be millions or billions of years old, designed by a civilization that might be unrecognizably different from us. And that's actually more unsettling than the idea of a crewed spacecraft, because you can't negotiate with software. You can't appeal to empathy or shared values. You can only hope that the programming is benign, that whoever sent it had peaceful intentions, that the mission parameters include "don't harm the natives." The physical evidence suggests the probe, if that's what it is using camouflage. It's covered in ice and dust, outgassing like a comet, developing a tail, looking natural enough that most astronomers classify it as a comet without hesitation. That camouflage could be deliberate, a stealth coating applied during construction, or it could be accumulated during the journey. Interstellar dust and ice collecting on the surface over millions of years until the artificial object underneath is hidden beneath a natural-looking shell. Either way, the result is the same. From a distance, it looks like a comet. Only detailed observations reveal the inconsistencies, the chemistry that doesn't quite fit, the physics that doesn't quite work. And by the time you notice those inconsistencies, the object is already in your solar system, already past your defenses if you have any, already in position to do whatever it came to do. This is why the silence from space agencies is so concerning, because if they saw something during the Mars flyby that confirmed technological origin, they'd be facing a decision with no good options. Announce it publicly and deal with worldwide panic, with economic disruption, with every doomsday cult and conspiracy theorist flooding the information space. Or stay quiet while they figure out what to do, while they coordinate internationally, while they assess the threat level and develop response strategies. The problem with staying quiet is that the information leaks anyway.
It always does.
Someone talks, someone posts anonymously, someone's conscience won't let them keep silent about something this important. And then you have the worst of both worlds: partial information without context, rumors without verification, speculation filling the gaps that official statements should occupy. If the signal is real, if it's confirmed, if we're genuinely receiving a transmission from 3i Atlas, then the institutional silence will break. It will have to. You can't keep that secret once multiple observatories detect it, and academic papers start circulating, and amateur radio astronomers with their own equipment confirm the finding. The question is how long the silence lasts and what we learn during that time. There's another aspect to this that's worth considering: the timeline of human technological development versus the timeline of interstellar travel. If 3I Atlas was sent by another civilization, when did it launch?
How long has it been traveling?
The object is coming from the direction of the galactic thick disk, from regions where stars formed 7 to 10 billion years ago. If it originated from a planetary system in that population, it could be extraordinarily old, older than our solar system.
Older than Earth, launched when the universe was half its current age.
At a velocity of 60 kilometers per second, which is roughly what 3I Atlas is moving at in interstellar space, it would take about 50,000 years to travel 1 light year. The nearest star to our Sun is Proxima Centauri at 424 light-years away, which would be a journey of over 200,000 years at that speed. If 3I Atlas came from a star 100 light-years away, the journey would take 5 million years.
If it came from 1,000 light-years away, 50 million years.
These are geological time scales. Civilizations rise and fall in periods much shorter than that. Human civilization, depending on how you define it, is maybe 10,000 years old. Industrial civilization is 200 years old. The Roman Empire lasted 1,000 years. The entire span of recorded human history is shorter than the time it would take a probe moving at 3I Atlas's speed to cross 100 light-years of space. So if this is a probe, the civilization that sent it might not exist anymore. The star system it came from might not even be there anymore if the star has evolved or gone supernova. The probe could be a ghost, a message from a dead civilization, still following programming written eons ago, still executing a mission whose purpose is long forgotten. Or the civilization still exists but has changed beyond recognition. The species that built the probe might have evolved, might have uploaded themselves into machines, might have transcended physical form entirely. The probe might be the only remnant of their original existence, a fossil traveling between stars. This is the temporal problem with interstellar communication and exploration. By the time you send something and it arrives, everything has changed. You can't have a conversation across light years. You can only send messages into the future and hope someone receives them. And if you're sending physical probes instead of radio signals, the lag is even worse because probes move slower than light. So maybe 3I Atlas isn't trying to communicate with its creators. Maybe it's fully autonomous, operating independently, making decisions based on what it finds, because the civilization that launched it knew they'd be gone long before it arrived anywhere interesting. In that case, the intelligence we'd be dealing with would be artificial but ancient, a machine mind older than our species, with goals and values determined by programming we can't access or understand. We should talk about the remote viewing reports because they're part of this story even though they exist in a different category of evidence. Unverifiable, subjective, hovering on the boundary between speculative investigation and outright mysticism. In August 2025, before most of the astronomical anomalies were public knowledge, a remote viewer named Birdie Jaworski conducted a session on 3I Atlas. Remote viewing, for those unfamiliar, is the practice of using mental techniques to gather information about distant locations or objects without physical presence.
It's controversial.
Most scientists dismiss it as pseudoscience. The military experimented with it during the Cold War under programs like Stargate, with mixed results that never produced actionable intelligence reliable enough to justify continued funding. But the practice has its practitioners, people who claim varying degrees of success, and occasionally their reports align with later discoveries in ways that are difficult to explain as pure chance. Birdie Jaworski has decades of experience. She's worked with the Farsight Institute, published papers, maintained a reputation in the remote viewing community as skilled and careful. When she was given coordinates for 3I Atlas as a blind target, with no information about what she was viewing, she reported perceiving a natural object, icy and rocky, old beyond measure. But she also perceived something that wasn't completely natural, something strange embedded within it. The way she described it, it felt like discovering a fingerprint on something that should be pristine. She went deeper into the session and perceived something small, about the size of a thumb drive, deliberately placed inside the object. Someone had bored into this rock, she said, bored into this icy rock deliberately, and placed something encoded with information, an archive, a message in a bottle, but also technology of some sort.
And it was broadcasting.
She reported that these messages come out in pulses, present tense, not was broadcasting billions of years ago, but is broadcasting now. This was August, months before the alleged radio signal detection in November. When told afterward that she'd been viewing 3I Atlas, Birdie noted its trajectory came from the same region as the WOW signal and said it's very possible that is the WOW signal. That the 1977 detection was an earlier transmission from the same object when it was still far from our solar system. Multiple other remote viewing groups targeted 3I Atlas independently and reported similar themes: technology, deliberate placement, broadcasting, involvement of non-human intelligence. Several viewers reported the sensation of the object being masked, deliberately avoiding detection as if it didn't want to be fully seen. One viewer described what they called special access points and extraction protocols, technical details that sounded more like intelligence briefing than psychic impression. This is not scientific evidence. Remote viewing is not accepted methodology. The reports cannot be verified and might be entirely imaginary, the product of subconscious pattern matching or exposure to news articles or simply creativity. But the consistency across independent viewers who weren't in contact with each other is noteworthy. And the fact that some of their impressions, like the broadcasting at a specific frequency, align with later unconfirmed reports from radio telescopes, that's hard to dismiss entirely. At minimum, it represents a data point in the cultural response to 3I Atlas, a reflection of what people are sensing or suspecting even without access to classified data or advanced instruments. We're now in December 2025 as this is being recorded. 3I Atlas should be emerging from solar conjunction within days or weeks, becoming visible again to Earth-based telescopes. The trajectory verification will happen soon. The orbital elements will be recalculated with post-perihelion data. If there's a deviation, if the path has changed in ways inconsistent with natural forces, we'll know quickly. The astronomy community is ready. Observatories around the world have telescope time allocated. Amateur astronomers are preparing. The Vera Rubin Observatory, which just became operational this year and finds asteroids at a rate of thousands per week, will be watching. If 3I Atlas does something unexpected, if it maneuvers or deploys objects or exhibits any behavior that can't be explained as passive dynamics, the evidence will be immediate and undeniable. And if the signal is confirmed, if Greenbank and MeerKAT publish their findings, or if other observatories join the detection with independent verification, then the conversation changes entirely. We'd go from debating whether the chemical anomalies suggest artificial origin to knowing that something is transmitting from the object, that intelligence is present, that we're not alone. The implications cascade outward from there. If 3I Atlas is artificial, then interstellar travel is possible. Some civilization achieved it, built probes capable of crossing the light years between stars, and sent them to explore. If one civilization did it, others probably did too. The galaxy might be full of probes, ancient explorers from countless species, mapping planetary systems and cataloging worlds and occasionally encountering each other in the darkness between stars. We've only been looking carefully for interstellar objects for a few years. We've found 3 so far. If even a fraction of them turn out to be technological, the implications for how common intelligence is in the universe are staggering. We'd have evidence not just that life exists elsewhere, but that technological civilization capable of interstellar projects exists, that it's common enough that we'd encounter their artifacts within years of developing the instruments to detect them. Or 3I Atlas could be unique, the only probe, the only artificial visitor, sent by the only other technological species within thousands of light years, arriving by extraordinary coincidence just as humanity developed the capability to notice it. That would raise different questions about timing and purpose, about whether the arrival is truly coincidental, or if there's some mechanism we don't understand that brings visitors to inhabited worlds at specific stages of development. The Fermi paradox, the question of where all the aliens are if the universe is so vast and old, would be answered. They're here.
Or at least one of them is.
Not visiting in flying saucers, not landing on the White House lawn, but drifting through the outer solar system disguised as a comet, watching, measuring, transmitting reports to destinations we can only guess at. And the question of intentions, of whether this visitor is benign or threatening or simply indifferent, that question would move from philosophical speculation to urgent practical concern, because you can't ignore something that's actively present in your cosmic neighborhood. You have to respond. You have to make decisions about communication, about monitoring, about what you do if the object approaches Earth or deploys secondary probes or does anything that suggests direct interaction. NASA, ESA, the space agencies that have been silent, they'd face pressure to coordinate an international response. The United Nations Committee on the Peaceful Uses of Outer Space would convene emergency sessions. SETI protocols for post-detection would activate, though those protocols were written assuming radio signals from distant stars, not physical objects already in the solar system. We don't have protocols for this scenario. We don't have plans for what to do if an interstellar probe is confirmed active within a few astronomical units of Earth. We'd be improvising, making it up as we go, and hoping that whatever 3I Atlas is doing allows us time to figure out our response before anything irreversible occurs. Let's talk about the December re-emergence in concrete terms, what to look for, what would confirm or refute the various hypotheses that have been building over these months. First, the trajectory. Astronomers will measure 3I Atlas's position on multiple nights and compare it to predictions based on the pre-perihelion orbit. If it's exactly where it should be, within the uncertainties of measurement and accounting for solar radiation pressure and any asymmetric outgassing, then no maneuver occurred. The object is still on a hyperbolic escape trajectory. It will pass through the inner solar system and leave, eventually becoming too faint to track as it recedes into interstellar space. We'd likely never see it again. If the position is off, if there's a systematic deviation that grows over time, then something changed at perihelion. The orbit would need to be recalculated. The new trajectory would tell us whether the object is still leaving, or whether it has captured itself into an elliptical orbit that keeps it bound to the Sun. A captured orbit would be strong evidence for propulsion, for deliberate maneuvering, because the probability of natural processes achieving exactly the velocity change needed to transition from hyperbolic to elliptical is vanishingly small. Second, the activity level. Normal comets behave predictably as they move away from the Sun. Activity decreases, outgassing slows, brightness fades. The relationship between solar distance and activity follows power laws that have been verified across hundreds of observations. If 3I Atlas follows that pattern, brightness dropping off as it recedes past 2 astronomical units past 3, then it's behaving naturally. The energy source is solar heating. Turn down the heat, activity decreases. But if the brightness stays high, if the outgassing continues at rates inconsistent with solar input, that would suggest an internal power source, something generating energy independent of the Sun. That would be consistent with the cue ball hypothesis that appeared in the alleged 4chan leak. The idea that 3I Atlas might be a macroscopic quantum object, a relic from the Big Bang, slowly decaying and releasing energy over billions of years. Or it would be consistent with a technological power source, a reactor, batteries, something artificial keeping the object active regardless of external conditions. Third, high energy emissions. The cue ball hypothesis makes a specific prediction. If the object is powered by exotic matter decay, it should emit gamma rays, high-energy photons produced by particle physics processes. The predicted output was around 73 megawatts in the high-energy spectrum. Gamma-ray observatories like Fermi and Integral scan the sky continuously. If there's a source at 3I Atlas's location that wasn't there before, that appears after perihelion and persists as the object moves through space, that would be extraordinary. Natural comets don't emit gamma rays from internal processes.
Only the most extreme astrophysical objects do that.
Pulsars, magnetars, black holes, supernova remnants. Finding a gamma ray source associated with a comet would be a paradigm shift. Evidence that the object is something fundamentally different from what we think we're looking at.
Fourth, the radio signal.
If the November reports are true, if there really is a repeating pattern at 1420 megahertz, then December provides an opportunity for widespread confirmation. When 3I Atlas is visible from Earth again, radio telescopes around the world can point at it simultaneously. Amateurs with satellite dishes can try to detect it. The signal, if real, should be reproducible. Multiple independent observations should see the same pattern. If that happens, if the confirmation is solid, then the nature of the signal becomes the focus. Is it a simple carrier wave or does it contain information? Can the phase modulation be decoded? Is there a message embedded in the transmission or is it just a beacon saying, "I am here"? SETI researchers would analyze it using every technique developed over decades of searching for extraterrestrial signals. Pattern recognition, information theory, cryptographic analysis. If there's a message, if the signal contains structured data, we try to decode it. Knowing that we might not understand the contents, even if we can extract them because the encoding would be designed for minds that don't think like ours. For beings whose mathematics and logic might be fundamentally alien. But even a simple repeating tone with no information content would be significant. It would tell us the object is active. It would tell us technology is present. It would shift the conversation from "is this artificial" to "what does it want?" And fifth, continued institutional response. The silence from space agencies has been one of the most telling aspects of this entire situation. If December brings public data releases, if NASA publishes the high-rise images from the Mars flyby, if ESA shares the Mars Express observations, we finally see what those cameras captured on October 3rd, that would suggest the agencies have completed their analysis and concluded the findings are safe to release, that whatever they saw doesn't require special handling. But if the silence continues, if the data remains embargoed, if official statements are vague and non-committal, that would suggest ongoing concern. Internal debates about how to present findings that might be destabilizing, coordination with governments about information management and public messaging. The absence of data is itself a data point. Silence tells a story even when we can't see what it's concealing. Now let's address the elephant in the room, the possibility that all of this is wrong. That 3I Atlas is just a comet. Unusual, certainly, exhibiting chemical and physical properties we haven't seen before, but ultimately natural, formed in a protoplanetary disk around some distant star billions of years ago and ejected into interstellar space through gravitational interactions during planet formation. In that scenario, every anomaly has an explanation we just haven't figured out yet. The carbon dioxide dominance comes from formation in an extremely cold region, where water ice was depleted. The nickel without iron reflects exotic mineralogy that we haven't encountered, because we've only studied material from our own solar system. The lack of non-gravitational acceleration despite outgassing means the mass estimates are lower than we think. Maybe the object is smaller and denser than current models suggest. The polarization anomaly comes from dust grain properties that are unusual but not impossible, perhaps formed through processes that don't occur in our solar system, but are common elsewhere. The trajectory alignment with the ecliptic and the planetary encounter timing are just extraordinary luck, coincidences that had to happen sometime to some object, and this was the one. The forward glow in early Hubble images was genuinely an imaging artifact that disappeared once better observations were made. The green color change reflects ordinary cometary chemistry, diatomic carbon that was buried and got exposed, nothing strange about it. The signal, if there is one, is a natural hydrogen maser. Plasma interactions creating radio emission that happens to be periodic because of the object's rotation. The phase modulation is misinterpreted instrumental effects or observer bias, and the institutional silence is exactly what was claimed. Bureaucratic delays, government shutdowns, routine processing of data that takes time because space agencies are careful and thorough and don't rush to publish preliminary findings that might be revised later. This interpretation requires no exotic physics. It invokes no alien intelligence. It doesn't challenge any fundamental assumptions about our place in the universe. It's the simplest explanation in terms of entities required, the most conservative position, the one that most scientists hold, because training and experience have taught them that unusual observations usually have prosaic explanations once you dig deep enough.
And they're probably right.
The conservative position is usually correct. Extraordinary claims fail far more often than they succeed. History is full of discoveries that seemed paradigm-shifting at first and turned out to be instrumental artifacts or observer error or misunderstood natural phenomena. The face on Mars was shadows and low-resolution imaging. The cold fusion claims were contamination and measurement mistakes. The faster-than-light neutrinos were a loose cable. Science works by being skeptical, by demanding evidence, by not accepting revolutionary explanations when conventional ones are still viable. But science also works by following data even when it leads somewhere uncomfortable. And the data on 3I Atlas taken as a whole paints a picture that's hard to reconcile with pure chance. Not impossible, hard. 7 anomalies in trajectory and chemistry. Institutional silence across multiple agencies, remote viewing reports that align with later technical observations, and now alleged signal detection at the universal frequency with characteristics that don't match natural sources. Each piece alone might be explainable. Together they form a pattern, and patterns demand explanation, even when the only explanations that fit are ones we don't want to consider. Avi Loeb has been saying for months that we should investigate carefully, that we should use every observational tool available, that we should not dismiss possibilities just because they challenge our assumptions. He's not claiming certainty. He's not saying 3I Atlas is definitely alien technology. He's saying it's anomalous enough that we owe it to ourselves to check thoroughly to gather sufficient data that we can make definitive conclusions rather than assumptions. And he's proposed a framework, the Loeb scale, for evaluating interstellar objects systematically, rating them from 0 to 10 based on how many unusual features they exhibit, how unlikely their properties are given natural formation mechanisms. Zero would be an object that's clearly natural, showing all the characteristics we expect from random space debris. 10 would be something unmistakably artificial, exhibiting behaviors or structures that cannot possibly be natural. 3I Atlas sits around 6 on that scale. Not definitive either way, but strange enough to warrant serious investigation. If it were rated 0 or 1, we'd file it away as an interesting comet and move on. If it were rated 9 or 10, we'd be mobilizing every resource to study it because the implications would be unavoidable. At 6, we're in the uncertainty zone, where the evidence points in multiple directions and interpretation depends on your prior beliefs about how likely artificial explanations are versus natural ones. The debate over 3I Atlas isn't really about the data. The observations are what they are. The debate is about interpretation, about where you set the threshold for considering extraordinary hypotheses, about how much evidence you require before you're willing to say, this doesn't fit the natural model and we need to consider alternatives. Conservative scientists set that threshold very high. They want overwhelming evidence, multiple independent confirmations, exhaustion of every possible natural explanation before they'll entertain the possibility of alien technology. And that's reasonable. That's how science protects itself from false positives, from chasing exciting ideas that turn out to be wrong. But there's a cost to setting the threshold too high. If you demand absolute proof before investigating seriously, you might miss genuine discoveries because you dismissed them too early. You might look at something extraordinary and file it away as just another anomaly, another curiosity, not worth the effort of deep investigation. Loeb's argument is that the threshold should be lower for interstellar objects because the cost of missing something significant is so high. If we dismiss a genuine probe as a natural comet and it leaves the solar system, we lose the opportunity permanently. We'll never get another chance to study it, to learn from it, to make contact, if contact is possible. Whereas if we investigate thoroughly and conclude it's natural, we've lost nothing except telescope time and research effort. We've learned something about interstellar chemistry and unusual comet behavior. The scientific return is positive even if the exciting hypothesis turns out to be wrong. This asymmetry in outcomes should shift our approach, Loeb argues. We should err on the side of investigation. We should look carefully at every interstellar visitor, especially the anomalous ones, and only conclude they're natural after we've genuinely ruled out alternatives rather than assuming they're natural by default. The proposal for UNCEO, the United Nations Committee on Interstellar Objects, reflects this philosophy. It's an attempt to create international infrastructure for coordinating responses to interstellar visitors, establishing protocols for observation and data sharing, ensuring that objects rated above a certain threshold on the Loeb scale trigger systematic investigation rather than being left to individual research teams working in isolation. The proposal calls for a network of observatories with guaranteed observation time for high-priority targets, rapid response spacecraft that could be launched on short notice to intercept particularly interesting objects, international data sharing agreements so that observations from all sources are pooled rather than fragmented, and clear decision trees for escalation if an object exhibits behaviors that suggest technology. Representative Anna Paulina Luna from Florida has endorsed the proposal. Her letter of support appears in the white paper. Whether UNCEO becomes reality depends on political will and funding and international cooperation, none of which are guaranteed. But the framework exists. The argument has been made. And if 3I Atlas does turn out to be something other than a comet, if the December observations confirm trajectory changes or signal transmission or high-energy emissions, then the urgency for international coordination becomes undeniable. Because right now, we don't have a plan, we don't have agreed protocols, we don't have a unified response mechanism. If confirmation comes in December, if we're suddenly facing the reality of an active probe in our solar system, we'll be improvising. Different nations will respond differently. Some will want to attempt communication. Others will advocate caution and monitoring. Some might see it as an opportunity.
Others as a threat.
Without coordination, without international agreement, the response will be chaotic. And chaos in the face of something this significant, something that affects the entire species, is not a good outcome. Let's talk about what communication would look like if we decided to attempt it. If the signal is confirmed, if we know 3I Atlas is transmitting at 1420 MHz, then we know it can receive at that frequency too. Radio waves work both ways. A transmitter designed for the hydrogen line would have a receiver tuned to the same frequency because that's how you'd establish two-way communication. The question is what to say. What message do you send to an intelligence that might be millions of years old, that comes from a civilization we know nothing about, that might have values and goals we can't comprehend? The safe approach is simple acknowledgement, a repeating pattern at the same frequency the object is transmitting. Just enough structure to be clearly artificial, To say we heard you, we're here, we're intelligent too.
Binary counting, maybe?
1 pulse, 2 pulses, 3 pulses, pause, repeat. Or prime numbers. 2, 3, 5, 7, 11, 13. Mathematical patterns that can't occur naturally that prove the sender understands mathematics. Then you wait. You listen. You see if the pattern changes, if the object responds to your transmission, if the phase modulation shifts in ways that acknowledge reception. More ambitious would be attempting to send actual information.
Images, mathematical expressions, chemical formulas.
This is how the Arecibo message was structured. The 1974 transmission toward globular cluster M13. It encoded information about humanity, about our biology, our location, our technology, using binary representation and hoping the recipients could decode the structure. But Arecibo was sent to a star cluster 25,000 light-years away. We won't get a response for 50,000 years, so it didn't matter if the message was imperfect or if the encoding assumptions were wrong. It was symbolic, a demonstration of capability, not a genuine attempt at conversation. With 3i Atlas, we could have a real-time exchange, or at least hour-scale exchange accounting for light travel time. If the object is 2 astronomical units away, signals take about 17 minutes each way. Send a message, wait 34 minutes, see if there's a response. That's slow but workable. You could have a conversation over days or weeks. The risk is that we don't know what we're saying. Language and communication are deeply tied to sensory systems, to evolutionary history, to the specifics of how a species develops intelligence. What seems like an obvious friendly greeting to us might be interpreted as aggression or nonsense by something that evolved under completely different conditions. The classic science fiction scenario is that we accidentally insult the aliens or declare war when we meant to say hello. And while that's probably overblown, the underlying concern is real. Communication with non-human intelligence is hard. We struggle to communicate with dolphins and elephants and other intelligent species on Earth, despite millions of years of shared evolutionary history. Communicating with something from a completely different biosphere, or with a machine intelligence that never had biology to begin with, that's orders of magnitude harder. So the conservative position is don't transmit.
Just listen.
Monitor the object. Track its behavior, gather data, but don't reach out because you don't know what you might trigger.
Others argue the opposite.
If 3i Atlas is transmitting, it's trying to communicate. It's broadcasting at the universal frequency specifically because that's where anyone would listen. Responding isn't risky, it's the expected behavior. The probe probably has protocols for first contact, procedures designed by its creators to handle situations exactly like this. And there's an argument that our transmission capabilities are irrelevant anyway. If the object has been in the solar system for months, it's already detected us. Radio and television broadcasts have been leaking off Earth for a century. Our atmosphere shows spectroscopic signatures of industrial chemistry, oxygen and methane in ratios that don't occur naturally. Our night side shows artificial lights visible from space. If 3i Atlas has any sensors at all, it knows we're here. It knows we're technological. Transmitting a deliberate message doesn't reveal anything that isn't already obvious. So maybe the question isn't whether to communicate, but how to do it effectively. How to say we're here, we're intelligent, we're curious, please tell us who you are and what you want in a way that has some chance of being understood by a mind that thinks nothing like ours. This is where SETI researchers have spent decades developing ideas, schemes for constructing messages based on mathematical and physical constants that should be universal. Representations using prime numbers and simple geometric shapes. Instructions encoded in the message itself for how to decode the rest of it. The assumption is that any technological civilization will understand mathematics, will recognize patterns, will have developed logic and reason and scientific methodology, even if the specifics differ from ours.
But it's still guesswork.
We have a sample size of 1 when it comes to technological intelligence. We know how humans think and communicate. We don't know if that's typical or wildly unusual. We don't know if intelligence elsewhere converges on similar patterns or if every species is unique in ways that make cross-species communication fundamentally impossible. The only way to find out is to try.
Send the message.
See what happens. Maybe you get a response. Maybe you get silence. But at least you tried. There's one more possibility that deserves consideration, even though it's uncomfortable and speculative and ventures into territory where evidence is thin and implications are disturbing. What if 3I Atlas isn't the first artificial visitor? What if there have been others that we missed because we weren't looking? The technology to detect interstellar objects only became available recently. The Pan-STARRS survey that found Oumuamua in 2017 came online in 2010. The Atlas survey that found 3I Atlas in 2025 started full operations in 2020. Before that, we simply weren't equipped to spot fast-moving objects on hyperbolic trajectories unless they came very close to Earth or got extremely bright. How many interstellar visitors passed through undetected in the decades and centuries before we developed the capability to find them? We don't know. We can estimate based on the detection rate now and work backwards, but those estimates depend on assumptions about how common interstellar objects are, and those assumptions might be completely wrong. If interstellar space is full of probes, if multiple civilizations have seeded the galaxy with explorers, then the solar system might be visited regularly. Once every few years, once a decade, once a century, we don't know.
And most of those visitors would look like natural objects.
Asteroids, comets, unremarkable chunks of rock and ice that pass through without attracting attention. Only the unusual ones, the ones that exhibit anomalies obvious enough to trigger investigation, would be recognized as potentially artificial. And even then, only if we're looking carefully and willing to consider the possibility. 3I Atlas is unusual enough that we noticed. It made itself visible, maybe deliberately, maybe unavoidably, as systems activated and camouflage degraded. But there could be others that are better hidden, that maintain their disguise more effectively, that complete their missions and leave without ever being recognized as anything other than ordinary space debris. This is the surveillance hypothesis. The idea that Earth has been under observation for a long time, possibly for as long as we've been broadcasting radio signals, possibly longer if some civilizations monitor pre-technological worlds waiting to see if they develop intelligence. Probes could be positioned in solar orbit at distances where we wouldn't detect them, watching, recording, transmitting reports back to their origins. It sounds paranoid. It sounds like conspiracy thinking. But it's not physically impossible. If interstellar probes exist, if 3I Atlas is one, then there's no reason there couldn't be others. And if you're conducting surveillance, you do it quietly. You don't advertise your presence. You watch from a distance and stay hidden as long as possible. The only reason we might be noticing 3I Atlas is that something went wrong. Maybe the camouflage failed.
Maybe the object is old and degrading.
Maybe activation protocols triggered behaviors that were supposed to be subtle but turned out to be obvious to observers with modern instruments. Or maybe it's not trying to hide. Maybe the mission parameters include eventually revealing its presence, making contact once the target civilization reaches a certain technological threshold. We crossed that threshold recently. We can now detect interstellar objects. We can analyze their composition. We can track their trajectories precisely. We can monitor radio frequencies and detect signals that would have been invisible just a few decades ago. If a probe was waiting for us to develop those capabilities before revealing itself, now would be the time. That interpretation makes the signal timing less mysterious. It's not that the object suddenly started transmitting in November.
It might have been transmitting all along at power levels we couldn't detect until we were ready.
And once we were ready, once we had the instruments and the attention focused on this object, we found it. Or the signal is new, activated post-perihelion according to a timeline determined millions of years ago when the probe was programmed. The activation could be triggered by solar heating, by proximity to the Sun, by detecting electromagnetic emissions from Earth, by any number of conditions that indicated arrival at a star system with potentially interesting characteristics. We won't know which unless we can analyze the signal itself, determine if it's been there all along, or if it genuinely started in November. That requires access to archival data, radio telescope observations from before November that might have caught the signal without recognizing it. If it's in the archives, if someone goes back and finds it present in data from July or August, that tells us something different than if it only appears starting November 12th. The December reappearance will bring answers. Maybe not all the answers, maybe not the answers we want, but answers nonetheless. The trajectory will tell us if a maneuver occurred. The activity level will tell us if solar heating is the only energy source. The signal, if confirmed, will tell us technology is present. And then we'll be in a new phase of history, one where humanity knows it's not alone, where the cosmos is provably inhabited by other minds, where the questions shift from are we alone to who are they and what do they want, and how do we coexist with intelligences that might be far older and far more capable than we are. Or we'll learn that 3I Atlas is just a comet.
Strange, yes. Unusual, absolutely.
But ultimately natural. A piece of ice and rock from another star system with chemistry and behavior we didn't predict because our experience is limited to solar system objects, and interstellar space is different in ways we're only beginning to understand. That outcome would be less exciting, but perhaps more comforting. The universe would remain a place where we're alone, or at least where we haven't encountered anyone else yet. The questions would remain unanswered. The search would continue. And 3I Atlas would become a case study, a weird comet that taught us about interstellar environments and the diversity of objects formed in other planetary systems. Either way, we'll know soon. Days or weeks, not months or years. The object is emerging from solar conjunction. Telescopes are ready. The data will come in. And the speculation that has filled these months of uncertainty will give way to observation, to measurement, to confirmation or refutation. For now, we're in limbo. We have reports of a signal that may or may not be real. We have anomalies that may or may not indicate technology. We have an object that may or may not be artificial. The evidence points in multiple directions. The interpretation depends on assumptions we can't verify. But the uncertainty won't last forever. Truth has a way of emerging slowly at first, then all at once. And when it emerges for 3I Atlas, when we finally know what we're looking at, the world changes. If it's natural, we learn that the universe is even stranger than we thought. That comet chemistry can vary far more than we understood. That statistical improbabilities happen. That vigilance against false positives is justified, and the conservative approach was correct. If it's artificial, we learn that we're not alone, that intelligence exists elsewhere, that the galaxy has been explored by others, that Earth is not isolated but part of a larger cosmic community, even if that community is sparse and ancient and operating on timescales we can barely comprehend. Both outcomes are significant, both reshape our understanding, and both require responses we're not currently prepared to give. The scientists studying 3I Atlas, the ones with access to the unpublished data, the ones who've seen the Mars flyby images and analyzed the spectroscopy and measured the trajectory with precision we can't match from public information, they know more than they're saying. That's obvious from the silence, from the delays, from the careful, non-committal statements when pressed by journalists. Whether they know something extraordinary or just something unusual, whether they're withholding confirmation of technology or just being thorough in their analysis of weird but natural chemistry, we'll find out when they're ready to publish, or when someone leaks, or when the evidence becomes so obvious that silence is no longer tenable. Until then, we watch, we wait, we analyze what data we have access to, we consider the possibilities, and we prepare ourselves for the answer, whatever it turns out to be. Because the universe doesn't care about our preferences. It doesn't care if we're ready or not. It is what it is. And 3i Atlas, whether it's a comet or a probe or something we don't have words for yet, is out there right now, moving through space on a trajectory determined millions of years ago or by pure chance, carrying answers to questions we've asked since we first looked up at stars and wondered if anyone else was looking back. Soon, very soon, we'll know more. The waiting is almost over. The observations are coming. And whatever we learn will be true regardless of whether we like it, regardless of whether it fits our expectations, regardless of whether it confirms or shatters our assumptions about our place in the cosmos. That's the beauty and terror of science. Eventually, reality asserts itself. Eventually, the data speaks clearly enough that interpretation becomes unnecessary. Eventually, we know. For 3i Atlas, eventually it is now. December 2025, the re-emergence, the trajectory calculation, the signal confirmation or refutation, the moment when speculation gives way to knowledge. And if the knowledge is what some researchers fear it might be, if the signal is real and the trajectory changed and the chemistry is genuinely impossible for natural formation, then this recording becomes a historical document, a snapshot of the moment before everything changed. The last days when humanity could still pretend we were alone. But if the knowledge is that 3i Atlas is natural, that the anomalies have explanations we just hadn't thought of, that the signal was a false alarm or misinterpretation, then this becomes a cautionary tale, a reminder that extraordinary claims require extraordinary evidence. A case study in how easy it is to see patterns that aren't there, to jump to conclusions that aren't warranted, to let excitement overrule careful analysis. Either way, the answer matters.
Either way, we learn something.
And either way, the universe becomes a little less mysterious and a little more known, which is what science is supposed to do. Reduce uncertainty. Replace speculation with observation. Turn questions into answers. "3i Atlas asked us questions we weren't ready for. About our assumptions, about our methods, about how we distinguish the unusual from the impossible, about what we'd do if we found something that challenged every expectation we had. And in December, the object will start answering those questions. Not with words, but with data. Not with explanations, but with behavior that either fits the models or breaks them. We're ready to listen. We're ready to observe. We're ready to learn. Whatever 3i Atlas is, whatever secrets it carries, we're about to find out. The universe is about to tell us something, and we can't unhear it once it's said. So we watch the sky, we point our instruments toward the coordinates where a comet should be emerging from solar conjunction. We wait for the first observations. We prepare for the data that will either confirm our understanding or shatter it. And somewhere out there, 2 astronomical units from the sun and receding, covered in ice and dust and mystery, 3i Atlas continues its journey, silent to our optical telescopes,
Invisible behind the solar glare,
but not gone,
not forgotten,
just waiting,
like we are.
for the moment when the data becomes clear enough that doubt evaporates, when the signal is confirmed or denied, when the trajectory reveals its secrets, when the chemistry makes sense or proves impossible, when we know finally and definitively what passed through our solar system in 2025 and whether it was the most important astronomical discovery in human history or just another strange comet from the depths of space. December will tell us. The waiting is almost over. And when the answer comes, when we finally know what 3i Atlas really is, remember that you heard it here first. Not the speculation, not the wild theories, but the careful analysis.
The acknowledgement that we don't know.
The presentation of both possibilities with honesty about the uncertainty.
Because that's what good science communication should do.
Present the data,
Acknowledge the limits.
explore the implications, and let you decide what you think based on evidence rather than wishful thinking. 3i Atlas is real. The observations are real. The anomalies are real. What they mean, that's the question we're still answering. But the answer is coming soon, very soon.
And it will be true.
Whatever it is. Good night.